this drive I'm working on here is an Amiga 2000 drive that I had written previously. Has write errors, alignment seems okay, question mark, maybe bad cap, question mark, and I was pretty right about that. So I got this drive out and I was looking it over and I was saying, okay, well, let me check the caps. Now what I did was I first tried to just align it, just trying to find, the first thing I do is try to find the test point on here that I can actually get a signal from the read head, from the, you know, the heads. And I think that's why there's always two, because there's two heads, and I imagine, you know, so we got like T1 and T2, or TP1 and TP2. So they're usually in pairs like that from each head, and if you get a different signal from one head to the other, from one test point to the other, if you're fairly certain, because again, these things, if they had a schematic or a service manual, you could, you know, you could just read it and find out exactly where it is and just test it from there. But I have to go hunting for it. So, and if those two signals are off, it means the two heads are probably not aligned with each other. So that means since the bottom head is usually fixed, you can usually align the top head to it. And people have said that you just take the carriage out and get the heads so that the top head is resting on the bottom head, and then just kind of eyeball it. But you know, really the best way to do it would be to simply run a two-channel scope, one on the top head and one on the bottom head, and then get both signals up on your oscilloscope and make them even. Adjust the top head until they're even, and then from there you work on the track alignment. So in that case you only need to use one of the test points. So, but this drive I was looking at for a test point on it, and I noticed that there were a couple. First of all, when I was trying to find the test points, I was probing around for them because they're not marked here. I mean, there is one that's marked TP or TZS, and it looks like it's a test point, but it says TZS. It's got a ground and 4 pins, but when I was looking at it, when I was probing it, it didn't look right. The signals didn't look right. And actually, you know what, it's probably this right here. It's already got jumpers on it. See if I can zoom in. I don't know. I think I'll need to get some magnification, extra magnification. Oh, you can see it good enough anyway. I'm going to get some extra magnification a little later. Let me get something to point with. This is the test. This is what I was looking for right here. That's the thing. You're looking around for paths, and you completely miss. This is obviously a factory installed jumper, probably to align the heads on top. That's probably what I want to latch onto when I do my testing. Anyway, so when I was running the drive using Amiga Test Kit, just had the motor running, probing around to see where I could find a valid signal. The motor was making a funny noise. It was basically going like this. Here, let's check the disc. It was making an intermittent, like, scraping sound or whatever, and you know, I'm like, well, that's probably the problem, because the motor can't be running if there's something scraping on it. But then I started to think about the scraping sound and how it may have sounded like, no, it sounded like a DC motor that was being pumped with AC. It'll still run, but it'll sound really weird. So it was sounding like it was scraping. I could even turn the motor on without a disc in there. It would still make the same noise. It didn't have anything to do with the disc. So I started to look around here, and I noticed that there were two caps that were pretty corroded. And the one that was really bad I replaced. And then when I did that, the drive works. It's perfect. Let me get you some extra magnification so you can see what I'm talking about. Okay, so here you can see pretty well. What we have, there is a cap that I also need to replace, this one. And you can see the corrosion on the pads right there, and there's actually corrosion on the nearby pads, this one and this what is this, a resistor? And over here there's like some corrosion on this trace. And compare it to these, you know, solder. So I was looking around to see where there was a test point, and I was also looking for bad capacitors, because that's what I wrote down, and sure enough I found one that was bad, and I'll show you that one right now. Okay, so this is the one that I replaced, and it's the original one has a really odd value, 3.3 microfarad. Turn it the other way. 3.3 microfarad at 50 volts. I dare you to find a 3.3 microfarad. So I put the closest thing I had. Well, a 2.2 was probably closer, but 4.7, you know, I figured go bigger, if any. So I put a 4.7 capacitor in here in its place, and it was a bit of trouble. I'll demonstrate it on, we're going to recap that other capacitor. I had a couple of problems with this one. The first one obviously is that everything was covered with corrosion, the two pads. And when I measured it with an ESR meter, and it was not even registering, or it was registering as a transistor, which means it was registering something else. That doesn't surprise me that there'd be a transistor like run in parallel or whatever with this, because it has something to do with powering the motor. And the motor was basically, this capacitor, it turned out, was open. It was actually open, and so it's not doing its job, and it's basically sending unfiltered electricity current to the motor, and just, you know, the motor was like, hey man, this is, you know, not cool, and it was just all over the place. The motor was constantly turning on and off, like, you know, dozens or hundreds of times per minute or whatever. It was, so it basically had the effect of making it sound like somebody was, like it was intermittently scraping on something. It was actually the motor turning on and off a bunch of times, and transmitting that noise into the flywheel. So anyway, I had to scrape off some of the corrosion, get some flux on there, get my solder to penetrate. Some people like to remove caps with hot air. That's not a bad idea. No way are you getting a cap off that has corrosion with hot air, because the corrosion acts as a barrier. So you got to at least get the corrosion off. And it's the solder blobs on circuit boards are never even. You're never going to be able to scrape them perfectly. So I dare say it's pretty futile to try to use hot air to remove an SMD cap that is leaked. So you know, so I just scraped off as much as I could until I could get my soldering iron with some fresh solder and some flux added also. So the solder's got flux in it, and I've got flux independently squirting on there, and I finally got the pads molten as far as I could tell, and then I just use my technique where I just move it just a little bit on one side when I get the side molten, and then I go to the other side. So it's a back and forth thing, and like I said, I'll demonstrate that on the other cap. But anyway, so and in the process of doing that, because there's so much corrosion will eat the glue that holds the pads down. This pad on this side lifted up, but it only lifted up on the corner underneath the capacitor. So it didn't actually lift up like right here. It lifted up like underneath the capacitor. So I was good to go on that. I could just leave that alone, flatten it back down, and solder. I'm soldering to the point of the pad that's still secured to the board. So we're good there. Anyway, so we'll go over to the workbench and replace this other capacitor and clean up the mess. best we can. Now this drive works now. I fixed that problem and it's working, but we can't leave this capacitor in place leaking. And there is, I did show earlier on accident, another capacitor, and it looks to be in good shape. It's right over here. It looks to be in good shape. I don't know if I should bother to replace it. It's a 10 microfarad 16 volts, so I guess if I have one of those I'll go ahead and replace that too. Anyway, let's change over to the Workbench. So you can see where it leaked out right there. And you know, I believe that it just stained the coating. I'm not sure there's really a way that it would under normal circumstances, get into the trace underneath. So 33, huh? I probably have a 22, yep, and a 47. So we're going to do what we did last time. We're going to go over. Here's our 47. The 47 is at 35 volts, so that's good too. We have this marked with our negative. Okay, I'm just going to replace that one over there that looks fine. I'm going to go ahead and do it anyway. And then we'll go back and test it. So let's check these three capacitors. This is the one that was definitely problematic. It was the first one I replaced, and it made the drive start working when I replaced it. Okay, so it's open. That's what that means. Let's try this second one. Yeah, this one's open too. Doesn't surprise me. It was it had also leaked. So let's check the one that okay, so that's it's coming up at 11.79 microfarad. So the one that wasn't corroded was probably fine, but we replaced it. The only other thing I have to do is just to make sure my connections are good. I'm just going to use my continuity tester and make sure that I haven't shorted anything, and that the capacitors are connected properly to their traces. Okay, let's test it, make sure we haven't messed anything up. I actually like this AMI alignment utility because it loads a full copy of Workbench, well, a basic version of it, and then proceeds to load the AMI software. See, it's still loading even though Workbench is up. So it's loading most of what's contained on the disk without me having to really click icons or start playing a game or whatever. And there we go. So let me set up the oscilloscope real quick. Okay, we're just going to boot into our Amiga test kit, and we're going to go to our floppy drive, and we're going to select DF1, and we're going to go to head calibration. There we go. Alright, so let's check out those those test points that we found, that we overlooked. Oh yeah, bingo. Alright, so the middle pin is probably a ground. But the two outside pins are the two heads. We don't have a very good ground. Let's try the case. Yeah, that's better. Alright, so we're at 5 millivolts per division. So we're running just under 10. So the question is do I mess with the alignment? Because I may have messed with the alignment trying to get this drive to work. I think I did. Let's check it out if we can see if the Loctite has been messed with. Yeah, I think so. So I dicked around with this one, which means we should probably align it. So let me solder a wire onto that to get us our signal so we can turn the drive upside down. And let's see, that's pretty cool. They designed an actual connector onto the board. So yeah, I actually don't need to solder. If I have a jumper that I can fit on there, I'll just do that. Either way. Okay, so here we got our DF1. Yeah, DF1. Always good to verify that. And those, I had a jumper that fit into that, a small. That's why you keep your old wires. So let's see if we can't get a fatter signal out of there, shall we? Is the right size? Probably not. This one is. Ooh. Yeah, our signal's getting bigger. I don't think I have messed with this drive because the Loctite is, well, it's got everything locked in there. There. No. No. This Loctite is really annoying. What happened? Screensaver. Okay. See, we do have a correlation between the two. Turn that off. So we can see that Amiga test kit says, hey, no way, man. And then we're going to move it and we're going to see our wave come up here and then it's going to say it's okay, but that is not okay. That is not enough. So, you could use Amiga test kit to get a very coarse adjustment by itself, but you are going to need to go a little farther into it than that if you want. Looks like right about there. Is our sweet spot. Yeah. So we have 10, or we've got all the way up to 10 10 millivolts. You know, a 20 millivolt range. Yeah, in my experience, that's the bare minimum of what you need. And this drive, I mean, I got it a little bit better than what it was. So let's reconfigure and do final testing. So apples to apples, we're loading our AMI alignment disk floppy. Now, one thing I want to point out about this software and this drive is that I'm fairly certain that I used this software to try to diagnose this drive. And I did suspect that there was something wrong with the motor, but this software indicates 300 RPMs when I did the RPM test in it. So, you know, just because the drive is thinking, or maybe even probably doing 300 RPMs, doesn't mean that it's a consistent 300 RPM. And I'm pretty sure that's what was happening. The drive was speeding up and slowing down constantly, trying to equalize it. It has a speed sensor like a Hall effect or an optical sensor. It's on the side of the drum, the flywheel. So this is the pickup for the sensor. Focus. And there's a little you know, a little doodad there. Oh, it is a Hall sensor, because I'm pretty sure that's not optical, that's a magnet. And then this is a coil, and it senses when the magnet passes by. So the drive can maintain, I mean, the drive automatically has circuitry that helps it maintain 300 RPMs, but, you know, it was constantly working to try to preserve those 300 RPMs. And it normally does, but it, you know, I don't think it was being very successful. Now this is a disc that doesn't seem to work at all, and I doubt it's going to work now. I think it's just my luck with Maxell high density discs, converting them to be used for double density, is that they don't really work very well. I think I'm going to get read-write errors on this. Yeah, no, it's not going to work. Yeah, that disc is trash. So let's try this. I don't have a keyboard hooked up, so I gotta do a cold reset. This is again the last refuge. It's a copy, backup, you know. I'm not sure if this is going to be the end of the video, but if it is, we'll see you on the next one, friends.